So we're in Chapter 9, Arrays, working our way through the PowerPoint. I stated that we were going to have an exam coming up over Chapters 6, 7, 9, and 10. Looks like I got the date wrong. It's not going to close on September 2. That'd be a real trick. Let's make that October 2. Do I really think we're going to get through Chapters 9 and 10 in 2 weeks, which is what this would require? I think so. Maybe we ought to move it back a week. I'd be more comfortable making it the 6th through the 9th. All right, so we'll post a update, but it's going to open October 6th. And close on the 10th, not the 9th. Then after that, we're going to get to object-oriented program concepts such as inheritance and interfaces and polymorphism. And that's some pretty cool stuff. So we talked about how to find the highest value, how to find the lowest value. I think we did how to search for a specific value. We wrote a little loop that would search for a value, and if it wasn't there, then it would return a -1. So there are other things we can do with arrays as well as that. The book goes on to talk about histograms and partially filled arrays, which I believe I mentioned a few lectures back, what a partially filled array is, and the idea of copying an array. And if you took computer science back in the 70s or in the 80s, before we had all these cool abstract data types like array lists and things like that, then you spent a lot of time writing code that would copy an array and that would sort an array and search an array and stuff like that. Nowadays there are helper classes which could do all this stuff for you. There's an array helper class which will copy the array. There's the array helper class can sort the array, that kind of stuff. But you still need to have the concepts. And the concept is similar to how you search the array, right? Or how you find the maximum. You have to just start at the beginning of the array and keep going to the end. So we're going to create an array that's got a couple of values in it, and then we're going to write a copy, some copy code. And heck, maybe we're going to be really cool and make that a method. So let's open up Visual Studio. No, let's not open up Visual Studio. I'm not programming Java in Visual Studio. NetBeans is a better choice. Long time back, Microsoft did support Java inside Visual Studio, but they extended Visual Studio with all sorts of extensions, and Sun Microsystems, who had the copyright on it, sued Microsoft for a lot of money. Microsoft's goal was to make it so that you could only run Java programs on Windows machines rather than on umpteen different million machines. Didn't work. So they took it out and wrote C# instead. That's neither here nor there. So I'm creating a new application. I'm watching a wheel spin. Not sure why. But I need an array full of numbers. And yeah, it'd be cool to go ahead and use that random code that we did last time, but let's just create an array of values. So, an array of ints. How about a really clever name? A1 for array 1, or AR1 is equal to, and let's give it an initializer list, 12. Just type in a whole bunch of numbers separated by commas. It doesn't matter how many numbers you type. Don't type my same numbers. Just get some numbers in there. All right. Now let's write some code that will copy that array. We'll write it inline inside main first, and then we'll move it up to a function for fun. And then we'll look at the helper class called arrays that will do the copy for you. So let's write some code. Copy the array to a new array. What's that going to require? One, we have to allocate it, right? Allocate the array. And then two, we have to loop through the array, copying each value in turn. And this could be a little bit more complex if you're copying an array of objects. And we'll learn more about that later. But if you're copying objects, are you copying the data that's inside the object? No, you're just copying references to the objects. And when we were done, we would have two arrays that all pointed to the same elements. But these are primitive data types, so we're good. So let's allocate our array. We need a new array. Int, what am I going to call it? AR copy, AR2. Int array AR2 is equal to new int, and we need to know the length of that first array so we know how many to allocate. How do we get the length of the array? Just AR dot length. Now we need a loop. And as always, there's more than one way to write a loop. I'm feeling primitive. Let's write an old school while loop. Let's get an index counter. Int index is equal to 0 while the index is less than the length of the AR1 array. They're the same length, right? We could use this AR2.length if we wanted. Then AR2 at that index position is equal to AR1 at that index position. And if I was an old school C++ C programmer, I'd tack on a ++ there and call my loop done. But we don't feel like being sneaky like that. We're going to stick the increment on its own line. And in one of our textbooks, it said that if you evaluate it and put the ++ in front of it, then it goes faster. My habit is to always put the ++ after it unless I need to do it the other way, so that's good. All right, and then let's print the array out. Now, let's do it the easy way. System.out.println AR1 equals %s/n AR2 equals %s. I'm going to have to change that to printf, right? %s/n, comma, after the quotes. What the heck did you put there? Alrighty. First things first. This should have been a printf. And the two things we're going to want to print is arrays.toString AR1. Why didn't I separate this into two print statements? Yeah. All right. So just AR1 is equal to %s/n, end quote, comma, arrays with a capital A, that's our helper class, dot, toString, parentheses, and then AR1 because that's the array we're printing out. And then a final closing parentheses. Then I'm going to copy that line and paste it. And just change AR1 to AR2 everywhere. As always, I hit the home key to go to the beginning of the line, hit shift down to copy all that stuff. If you're using Mac, then your keyboard shortcuts are completely different, so I can't help you there. AR2, AR2. Let's run it and see if we got a copy of it made. And it worked. We copied our arrays. Alrighty, so that's how we could copy the array. Let's write a method that does the same thing. Maybe instead of a while loop, we'll use a for loop. Going to be remarkably the same, right? Okay, so let's come up here and add a method on called array copy. Public static void array copy I'm not digging making it a void. Let's make it return the array. So public static int square braces array copy, and what we take in is the array to copy. So int square braces AR for array. Same kind of business. We need to allocate the array, allocate the new array, loop, copying the values into the new array, and then return the new array. So let's do that. Int square brace in square brace AR2 int A for new array. How about AR2 is equal to new int out to the length of the AR array, which is our original array, AR.length. Now let's fill it. I'm resisting the urge to use a for each loop. That would be stupid. Okay, so for int I is equal to 0, I is less than the length of one of the arrays, I plus plus, and then AR2 subscript I is equal to AR subscript I. Maybe I should have called it AR1 like I did downstairs. And then we need to return our new array. Why did I do that? Because Java, well, we don't have a new array to copy it into. I guess we could write some code that would do that. But we don't have a new array to copy into, so we're just going to return our brand new array. So that's our code for copying an array as a method. And let's go use it. Notice that it's offering helpfully to change this completely. Manual array copy. Replace with system array.copy. Neat. I'm going to undo that.
What is that? Whoa, that didn't even look right.
Yeah, that wasn't even using the arrays helper class, which came in a later version of Java. It uses a system function, which shipped in the very first version of Java. Let's go back down here and use our new array copy. So let's make an int a reference to an array, AR3, but we're not going to allocate it because we're going to then do AR3 is equal to array copy of AR2. Then let's print it out. System.out.printf AR3 equals %s \n. Same kind of business. Arrays.toString AR3. And let's see if it works. Hammer room to build it, green arrow to run it. Yeah, so we have 3 arrays. And we could prove that they're different by changing the values in one of the arrays and printing out the other 2, but they are different. If you feel like making that change, trying it out, that's fine. Just because I'm a fan of making things look kind of blocky and modular, I'm going to cut those 2 printfs and paste them down here with the last printf because I think that's prettier. All right, we've talked about how to copy an array. There's 2 other ways. You may have noticed that on our for loop up here, as I mentioned, you could change it to copy it like that. And so here we're calling system.arrayCopy. Here's our source array starting at position 0. Here's our destination array starting at position 0, and this is how many elements you want to copy. Want to do that? That's fine. There's another way too. Arrays dot copy of, and then you give it the original array. So we could do AR2 is equal to arrays dot copy of AR. But it's wanting me to fill in the second parameter. Why don't we look at the Javadoc for the copy of method? So I'm going to highlight copy of, do show Javadoc. Copy of is where you give the original array and then you give the new length. What's the new length going to be? Just the length of our original array. So AR.length. I would prefer to do it with arrays.copy of rather than that. But this one's kind of funky because if you want to copy elements 10 through 20 of your array into a new array, but making those positions 30 through 40, you can do that. I think that's the cleanest syntax, though. I'd remember that one. I'd tuck that one away. Now, on an exam, if I ask you to write an array copy using a for loop or a while loop, don't just type arrays.copy of, okay? Same thing for printing an array. If I ask you to print an array with a loop, don't just use arrays.toString. But that's incredibly useful, isn't it? At least for debug purposes. The user may not want to see a list of names in this format where you have, you know, square braces around it and it's all separated, you know. So there are times when, okay, so that's one-dimensional arrays. I'm going to skip the idea of histograms. We're just going to go on to the next idea, which is two-dimensional arrays. But maybe I should do an array of objects first. Let's make an object, a class. Doesn't have to be serious business. I'm going to go out to my projects, and out next to my package folder, I'm going to right-click and do new Java class. And we're going to do a point class that's got an X and a Y coordinate. Your name at the top of it, which we should have done on the other one, and this is September 13th notes. Point class with X and Y coordinates. All right, this is going to be a real simple point class. It's going to have one constructor, and I'm just going to leave, I'm not going to even add getters and setters. That's pretty atrocious. Okay, so int x comma y. Now, maybe we'll add a toString. Maybe we'll add a copy method. You know, all that's good stuff. So let's add our constructor first. Public, a constructor is a method that has the same name as the class, but we want it to accept an x and a y. What does it do? It sets this dot x equal to x, this dot y equals to y.
Cannot find symbol class y. Oh. I feel like they could have worded that their whole little, I guess like when they send you back like what error you made, sometimes it makes no sense to what.
Yeah, sometimes if you make a mistake, the error message is just really indecipherable because it's referring to something you did wrong earlier. Okay, so let's go ahead and add a toString method. Public string toString. I always recommend adding a toString method.
Don't forget your override.
Yeah. At override, that'll do it. Yeah, okay. So string s is equal, no, just string s. S equals string dot format. And inside our quotes, we're going to do the word point followed by a pair of parentheses, %d, comma, %d, end parentheses, end quote, and let's pass in x and y. And then let's return our string. I think that's enough for our class. So we have our point class. Let's go actually make some points. What is the point of this exercise? Alrighty. So point, let's just try it out first. Point P1 is equal to new point 10, comma 20. Point B2 is equal to new point 20, comma 30. And let's print those guys out. This is just to make sure it works, right? System.out.println P1 plus a \n plus P2. All right, so printed out point 10, comma 20 and point 20, comma 30. That worked. We can make arrays of objects. Just as easily as we can make arrays of anything else. So, you know, a triangle is defined by 3 points. So let's make an array that could hold 3 points.
Quick question. So whenever you need to print, well, if you call the toString method, it doesn't let you do it?
Well, you could call toString if you wanted to here.
I just did point.toString.
And that works. Yeah. If you want to, you could do p1.toString and then p2.toString, but you don't have to. Since they're being concatenated with a string anyways, Java will automatically call toString.
I just I did like the class point.toString because I thought it's not a class method, so I don't know why I did that.
So let's make an array of points. Point, square brackets, 3p for 3 points. Wish I could use a number there, but you can't create that as a variable name. Is equal to new point, and we want 3 of them. Now that looks a bit weird, right? Because when we use new here, we were using parentheses to create them. But that's because that's the constructor. This is just allocating a space for 3 references to points. We actually haven't created any points at all at that point. It's just a place in memory that can hold references to 3 point objects. Now let's create them. Little bitty loop. Have we int count is equal to 0, while count is less than the length of our loop of our array, while count is less than 3p dot length. Let's make a new point. Point p is equal to new point, and we need some values for it. Why not just use the counter? And then the counter again. It's just going to say 0, 0, 1, 1, and 2, 2. It'd be more fun to fill it full of random data. Now let's copy that into the array. 3p at position count. Now I'm wishing I'd done this as a for loop or something. I like I a lot better than using that whole word. Gonna do that. Sorry guys. I'm deleting the line int count. I'm rewriting it as for int I is equal to 0, I is less than 3p dot length, I plus plus. Our next line is point p is equal to new point I comma I. And then 3p at position I is equal to that new point. Do we have to do it in 2 steps like that? No, we could just put the new point I comma I right there. Now let's print out our array. We're going to again use arrays.toString, and arrays.toString is pretty cool because it's going to call the points toString to print them all out. Or so I predict. System.out.println 3p is equal to, followed by a plus sign, followed by arrays.toString, parentheses 3p. Should have called it 3po. Be a Star Wars nerd. Alrighty. There's a possibility that'll work. Let's give it a shot. Where'd my output go? It's right there. Why is it not letting me size my output larger? There we go. All right, so we have an array that's got 3 points. 0, 0.1, 0.2. Let's use a for each loop to print out our list of points now. For every point p that is in our 3p array, system.out.println that point. There we go, 0, 0.1, and 0.2. Printing it with a for loop rather than a for each loop. Getting redundant here, but for int I is equal to 0, I is less than the length of 3p, I plus plus, system.out.println 3p at position I. I've messed something up. Oh, 3p.length, excuse me. So I is less than 3p.length. I know that works, but I'm going to run it anyways. All right, so we've created arrays of objects. The thing to note about copying arrays is that if it's an array of objects, you're just getting copies that are references to the objects, and you have 2 arrays full of the same objects. Let's kind of prove that to ourselves. We're going to make a new array of points. Point AP new for a new array of points, or just new AP. It's going to be an array, so I'm going to put my square brackets there, is equal to new point. Why don't we just use the arrays.copy? So point new p is equal to arrays.copy of the original array, which is 3p, and the length of it is 3p.length. If we print that out, it's going to be the same, right? But let's change a value in the new array. So new AP position 1, we're going to change the second element of the new array to equal a new point, 10, 10. And now print out the original array, system.out.println 3p equals, end quote, plus arrays dot to, or is it just array dot toString? Yeah, array dot toString. (3p). And that was wrong. It is arrays. Where did I come up with array? Seemed like array actually started to pull up something. I'm going to have to pull that up. Anyways, our helper class is arrays. All right, so if we print it out. Oh, check it out. I was wrong. Comment this line out. That didn't prove the point. And now that I think about it, that's legit. Because we have two arrays full of references. But if we created a new reference and stuffed it in the new array, right? Change this so that it's printing out the original and then the new one. And then we're going to make one more change. So 3p is equal to that. And then new AP is equal to arrays.toString new A. They're not going to be the same. And that's legit because we changed the reference, an element in the new array, but that left the reference alone in the original array. But now we're going to do something that takes an effect in both arrays. So what we're going to do is we're going to say new AP element number 0 dot x coordinate is now equal to -100, right? And now just copy those two print statements and run them again. And you see that even though our original array, we weren't setting any values in the original array, it changed it for the original array. And I hope the reason for that is clear. I'm not going to draw any pictures or anything like that, but we have an array of objects, but it's actually references to those objects. So our first array has got a reference to object 1, a reference to object 2, and then a reference to object 3. That's our first array. Then we create another array that's got a reference to object 1 and a reference to object 2 and then a reference to object 3. Then we went along and we said, okay, that second array is a different point. So that created a new point, right? And so when we printed out the original array, it was still the same. And then this one had a new element there. But then we went in and we said, okay, reference 1, we're going to change your data. So that kind of modified him. I'm just going to put an M to say that that modified him. But it's still the same object. Both of them are pointing to that. I don't know why I typed capital O's rather than lowercase o's. You get the idea, though. So if you change the values of an object that's in more than one array, it's changed for every reference going to it, right? Because you have two street signs pointing to the same street. You change the colors of the houses on the street, that both signs are pointing to, those new values. Hope that's clear. What we would need to do is write a copy function that actually cloned the array, which created new points made from the old points. All right, I think that takes us to the end of the arrays chapter. Or not. We're only right here. I may have drastically misestimated that. Searching an array. We've talked about searching an array. You start at the beginning, you keep looping until you find the one you want, then you keep track of that index value. And if you never found it, then you leave the index value at -1, and that's what you check. Sorting an array. We did skip that. There are many different sorting algorithms with various degrees of complexity and efficiency. There's an algorithm called selection sort. And rather than walk you through this, I'll probably just post a link to a YouTube video on selection sorts. It's kind of cool. There are other sorts too that you can implement, bubble sorts and the like. That's why we're not done with the chapter. Two-dimensional arrays. Okay, this is a good thing to end on. Let's do the two-dimensional array. A two-dimensional array is just a grid, like an Excel spreadsheet. You know, it's got rows and columns. Let's make a two-dimensional array of our points. We really need some random numbers up in this guy to make it really more interesting, huh? Okay. So random rand is equal to new random in parentheses. Now we're going to have to go and add the import for the random class. So either go up to the top underneath the package statement and do import java.util.random, or I'm going to let the handy dandy NetBeans fill that in for me. Import java.util.random. See, there it is. And it's weird to me that it automatically filled that in for arrays. I do not remember adding an import for that.
You did it when you did arrays.toString.
Oh, I clicked on it? Okay. I just did it out of habit.
You click on it really fast.
I just kicked out. Okay. So I apologize, guys. I have a habit of going over here and clicking on the add the import. Okay. That way we can create a two-dimensional array full of points. So how do you declare a two-dimensional array? Let's first make a two-dimensional array of ints. As a matter of fact, let's just stick with ints rather than over-complex it with points. It's got two dimensions, so you need two square braces. I'm going to just call this one map. Is equal to new int. It's going to be a 5x5 array. Then let's get the height and the width of the array for later purposes. So the height of the array is just map.length. Sounds counterintuitive. And then the width of the array is equal to maybe the first rows. So map subscript 0.length. Now let's write a for loop that'll do those things. And instead of using I, I'm going to use R and C for row and column. So for R, int R is equal to 0. R is less than the height because we're counting rows. R plus plus. For int C is equal to 0. C is less than the width of the array. C++. I'm going to get rid of this width thing. Why? Because I like querying the array for its length on a row-by-row basis. And the reason for that is, although it's weird sounding, you could have arrays, two-dimensional arrays, where each row is a different length. That's called a ragged array or a jagged array, rather than a rectangular array. So anyways, I deleted that line about width, and so the width of the array is equal to this row's, map, map, square brackets, R in bracket, dot length. So you see what that's doing? We're asking this particular row for its length. Now let's make a new point. Point P is equal to new point, and let's fill it full of random numbers. rnd.next, what did I call it? Oh, rand, excuse me. New point, rand dot next int with an upper bound of 10, comma, and then a second, the y coordinate is also rend dot next int with an upper bound of 10. Didn't I say I wasn't going to not use points? Yeah, I said I wasn't going to use points. Sorry about that, guys. Map was supposed to be just an array of ints.
And we're supposed to fill that array with our random numbers?
Yeah, so, alrighty. We don't need to make a new point. Let's just make a new value. So map at position row, index column is equal to rend dot next int.
You said
10.
10.
Now if we print this array out with arrays dot toString, I don't know what that's going to do. I've never tried to print a 2D array out with arrays dot toString. System.out.println arrays dot toString map. Just curious.
What the? References. What?
Well, where's this stuff coming from? I guess I put some code underneath it. Oh, I did way down there. Alrighty. So I'm going to cut this map.
Just delete the bottom.
I'm going to cut all that code about the map, and I'm going to push it underneath these print statements. So, yeah, it didn't do what we expected it to do. So forget that. Instead, we're going to write our own code for printing the array out. And if we had to use a nested loop in order to fill the array with data, we have to use a nested loop in order to print it back out. Same kind of deal. For int r is equal to 0, r is less than the height of the array. And instead of height, you know what we could just do? Map.length. It seems counterintuitive, perhaps. You might think that that's equal, if you have a 10 by 10 array, that the length of it is 100. No, what it's doing is it's declaring an array of arrays. So if you don't specify any values, it's just returning the first number. And then if you specify the first value, it's returning the second number when you call .length. Now we need for C, for int C is equal to 0, C is less than map.length. That was supposed to be a semicolon here. Semicolon C++. System.out.printf %3d. I want to give each one 3 spaces. End quote. I didn't put a /n for a reason. And then print out the map at that coordinate. Map index r, index c. Now why didn't I use print line or put a /n? Because I wanted to print everything on that row before it goes to the next line. You know, just like a typewriter. We need to print all 5 elements, 0, 1, 2, 3, and 4. Then go to the next line. So outside of the inner loop, that's where we set our system.out.println. So that should print out our grid, our map. Oh, and look at that. He's offering to make a change for us. Use enhanced for loop to iterate over the array. Convert to for loop. Yeah, we could do something like that. Undo that. Alrighty.
That looks scary.
And there we go. Printed out our grid. This is position 0, 0. The first one indicates the row, the second one indicates the column. So that's position 1, 0. That's position 4, 0. This is position 0, 4, 1, 4, 2, 4, 3, 4, and 4, 4. We could prove that to ourselves. Let's set this value right here to a 99. So what position is that?
Position 3, 4, I think.
Would be, except the suggestion was position 3, 4, but we use zero-based counting, so that's row 0, 1, 2.
2, 3.
So it's 2, and then 0, 1, 2, 3, 2, 3. So before we print them out, map 2, map 3, or map 2, index 3 is equal to 99. And there we go. Nope, that's not, there we go. I haven't run it yet. All right, and it changed that one. All right, so homework for one-dimensional arrays. Ask the user how many numbers they want. Use that number to allocate the array named A1 of that length. Use a loop to fill A1 with random numbers between 0 and 99. Display A1 with your own loop. Don't use arrays.toString. Copy A1 into a new array using your own loop. Then display A2 using arrays.toString. Easier. Then copy A1 into a third array, A3, using arrays.copyOf. And then, because we love our minimum and our max and sums and averages, calculate and display the sum, average, min, and max of array 3. So last thing let's mention before we are done is if we feel like it, we could sort our array of ints, not by writing a method to do it. See, our original array was called AR1. Go down to the bottom of our code, way down to the bottom of our code, and do arrays.sort. I don't even know what it would do to try to sort a two-dimensional array. Just sort AR1 and then print AR1 out. System.out.println. Sorted AR1 equals plus arrays.toString of AR1. Let's make sure that works. And there we go. That looks pretty sorted to me. Let's tack that onto our homework somewhere. Copy A1 into a third array. Sort A3 using arrays.sort. And then calculate the sum, average, min, and max of A3. That makes sense?
Yep.
Alrighty.